Okay, so it turns out the poor old Norton cylinder head, she wasn't far off knackered. As we saw in the last video, for those of you that watched it anyway, the valve guides were absolutely shot. Now, when it came to removing said valve guides, where there's a nice array of a combination of cutting tools and measuring equipment out at the minute. The inlet guide, there she is. A little bit tough to get out, tougher than I expected. I had the head plenty warm enough. It was sat in the oven for sodding ages. Made a pull up. And like I said, tough to get out, but came out okay. You can see a bit of some of the marks there from pulling her out. I think the amount the valves were wobbling around, I think they've mushroomed the end slightly, making it hard to get out, of course. The exhaust valve, on the other hand, or the exhaust guide should I say, well, there's some of it, and there's a bit more, and so on. They're the bits I managed to group together. It came out in pieces. It was a git. It took sodding ages, but anyway, it's out, it's done. But unfortunately, the holes in the cylinder head for the guides to go in, by the time I got them out, were not in a nice state. You can't really see in this light. I've cleaned it up now, but I am above on the exhaust one. I think I'm just within on the inlet, but I am above on the exhaust, the maximum oversize you can buy. So we're going to have to make some guides. So there we go. There's a bit of bronze sat in the lathe waiting to go. I've not done a thing to it except for center it. That's all I've done. So yeah, we're going to machine down the outer. I've got the tolerances I want written down somewhere. And of course, pilot drill the end, then bore it out to suit the valves. But I figured since we're making our own guides, let's have some different valves, hopefully better valves. So that's one of the originals. They are 1.6 inch, or I think 40.6mm head on them, with a 3/8 stem. And by the time you got that guide down the ports and that giant stem, it's blocking quite a lot. And as you can see, it's the it's the same all the way down. So what I've found are these. This is a stainless steel valve. I think 7.88, I think 7.8, and it's somewhere around there, mil stem, and also it's wasted towards the valve head as well, so it should give us a lot better airflow. I believe these are out of a Ford Crossflow engine. They're not a standard one, they're an oversized thing. And then if we're doing that, we might as well have some better valve springs in, because let's face it, the ones that are in it, they've been in there 66 years. I think after 66 years they'll be ready. I mean, the government don't agree with that anymore. They think you have to be 68 for some reason, but you know, let's pretend they've saved up well, and yeah, let's retire them a couple of years early. And yeah, so we've got some nice new springs, single spring setup rather than the twin spring, just to reduce a little bit of weight in there. Let's put that back in the box, and yeah, hopefully it'll be okay. Well, yeah, well, since I figured, well, I wanted to try modifying a head. Let's move away from that light a bit, there we go. But didn't want to do anything to a good one, because, well, you know, they're getting old, there's fewer of them now. So I figured since this thing was half dead anyway, oh, and the seats were horrendous, just the amount those valves have been wobbling around, so I thought I might as well do something to this one. So yeah, let's turn her over. So I've left the exhaust side alone, it's plenty big enough. All I've done is clean it up a little bit and blended the seat in. Now the inlet, on the other hand, we've got nicely blended. You can't really see in this light, it's not finished yet, there's still some marks and bits I need to finish sanding out of there to make it right, but I've enlarged the bowl and no, you really can't see it properly on the camera. But anyway, as the inlet track comes through at this angle, the air is going to follow the outside of the curve, so it's going to want to be on the roof of the port, which is the bottom with it being upside down, and on this side. So I've put a bias on this bowl to bring the majority air around this side to hopefully help encourage swirl. And let's turn it over. There we go. We've taken her out. I've not gone silly with it. There is scope to go further. I've kept it well within the sort of range that'll keep really good port velocity and port energy. Yeah, I'd like to go further, but I don't want to ruin the head either, because there's an oil way down here. I don't want to punch into that. It is quite thin between here and the inside of the head at the rocker there. At least it feels to be. I could be completely wrong, it could be massively thick, but I don't want to take the chance of ruining it, and I don't want to go too far and, as I said before, ruin that velocity, because yeah, you don't want to be sacrificing that for airflow. So we've sort of stayed in the regions of okay, and then shorten the flange. There's a bit that came off, just so I can put an adapter on it, because of course the carburetors on these run ridiculously close to the oil tank. But let's get it down here. Yeah, by the time you've got the head on and the carburetor on, you've got the tiniest of gap between the carb and the oil tank, so there's no feasible way of running an air filter. You're sort of alright when you're on the twins with a single carb, because you've got this great big hole in between the battery box and the oil tank. So you can do what you like with that. You can either leave it open, you could even duct still air at it or something, but these things are breathing straight off that oil tank. They are. Yeah, it's not doing any favours at all, really. I mean, you know, the work, it does its job, but you know, we'd like it a little bit better. So I've done, as I said, I cut that off, started making an adapter, which I'll show you when I remember where I put this sodding thing. Maybe I won't show you. But anyway, since my carb is absolutely worn out, you just have to imagine the adapter plate. And I've got a really, really good SU carburetor. That is now the correct size for that port, or the port is now the correct size for that carburetor. I thought we'd give that a go because, well, new AML mono blocks are getting quite expensive. This isn't, this is off the shelf. This has been sat here for bloody yonks. I've got some paperwork for it somewhere to say it's all been reconditioned and bits. It might even be there. Yeah, I've got some paperwork to say it's all been reconditioned and whatnot. Came with a load of stuff I got yonks ago. So yeah, free and works is better than what I've got, because we are on quite a budget. And I would like to point out all these bits I'm changing. It's not costing me any more than putting original stuff in. Probably a little bit less actually. Yeah, I said combination of some car bits and then, like I said, making my own bits like the guides. So yeah, it's getting there, slowly. I've not even looked at the rocker arms yet. They are a little bit sticky. Yeah, I'm hoping it all cleans up okay, but you know, it's a problem for future me. Let's get one bit done at a time. The bore, not bad. It's still on standard size. There's a little bit of wear, you know, it's not brand new, but it's acceptable. The piston as well, not a lot of wear. There is a lot of oil, but there's not a lot of wear. And the reason for all the oil and the carbon down the sides is the old oil ring here. She is absolutely knackered. It has got stuck inside its groove. Oh, these blooming lights. There we go. Yeah, the oil ring groove on the piston, it's all a bit gelled up and manky. I don't quite know how well it comes across, But anyway, the oil ring had got itself stuck well and truly in, so was doing absolutely nothing in the way of clearing oil off the cylinder. And then the top ring, I might like to point out the middle ring, absolutely lovely. Brilliant gap on it, really nice and springy, does its job grand. The top ring's got a bit missing. Now luckily we did find it. It was still floating about. But yeah, quite how this thing ran at all, I'm really not sure. So yeah, that should sit in there somewhere. There you go, you sort of get the gist of that. So yeah, she was doing quite well to keep running. So yes, I'm a little bit conflicted with the barrel. I think if I can find a good set of standard size Hepalite rings, I think we'll clean that piston up and pop it back in for now. Like I said, there's somewhere on the barrel, but we should get the rest of the summer out of it. On the other hand, if I can't find a good set of rings for it, we'll just sort of plus 20 it, I think. Yeah, maybe plus 20. You could maybe get away with plus 10, but I would hate to buy a plus 10 piston, send it to get bored, and it not quite clean up all the marks correctly, and then have to buy another sodding piston and do it again. So yeah, like I said, she's all in bits. Oh, and as we're having a nice British summer, I've put the tent up out here so I can kick this thing out and well away from the swarf and bits without it getting wet and nasty. Right, I think I've waffled for long enough now. I'm going to have to edit this down a bit, aren't I? Okay. Right, I best get on with a little bit of work. Finish my tea first. Okay, onward. Well, the first stage went slightly better than expected. The smallest drill bit I had that was long enough to pilot this was a 5mm, so quite a big drill bit for a pilot. But the the hole's 50mm deep, so I was going 10 times the width of the drill bit, or 10 times the diameter of the drill bit in depth. And it's always a sketchy moment when you start doing things like that. But it managed it. Just took me time, a lot of peck drilling, and right. We'll go up to the. I'll take it out to the pilot size for the reamer. Yes. Not really going to film any of this because managing the backlash in this old lathe and making sure I get my measurements and bits bang on takes up most of the brain capacity. So yeah, I'll stop the camera again and we'll turn it back on when there's either a success or a failure. Rightio. Okay, well we've got it piloted out okay, and we're just running the reamer down. As it's a hand reamer and not a machine reamer, I'm simply holding it in the Jacob's chuck and I'm turning the chuck by hand, periodically stopping and cleaning out the swarf. It seems to be doing a nice job. Hopefully it'll be somewhere near dimension. The drill bit for the tapping size was a bit vicious. Sort of had to peck drill it all the way down because the pilot size was a little bit too big for it really, but it's all I had. So of course when you started cutting it just grabbed and tried to tow it in, so just gently peck drilled all the way down. This operation seems to be going quite nice and smooth. Right. Now carry on, bring you back for the next bit. exhaust valve guide. Obviously got to clean that bit off the top. Now, I made the exhaust one first, because of course they are ever so slightly... Oh, got the camera straight and get out of the way of that light. Kick everything over in the process. Right, yes, I made the exhaust one first because they are ever so slightly different dimensions. Exhaust one is slightly bigger. That way if I blew the outer dimension I wouldn't have wasted the bit of bronze, because, well, bronze is not expensive, idiot. Bronze is not cheap anymore, it is rather expensive, so, yeah, there we go. Yeah, we've gone for, what have we gone for? That's 16.25mm at that end. Should be a nice interference fit with the new hole I've had to cut. And that's just sort of whatever. I just did a skim pass to clean it up. As long as it fits inside the spring, it'll be okay. So yeah, I'll leave it to cool down now because it's rather warm from that parting operation. And I'll clean the sharp bits off, remeasure it, and we'll have to see about making something to drive it into the head with, because I don't fancy knocking the thing in. Yeah. I think that'll be a nice light interference fit. But like I said, we'll let it go cold. That way, if I have got it wrong, I can chuck it back in the lathe, take a little bit more off it, and use it on the inlet one instead. Right, I'll let this go cool. We'll see you in a minute. Well, let's just put a damper on things. Yeah, new valve doesn't fit in the guide. Ream them to 7.9. I've checked it. I know it's cold. I've put the reamer back down it again. I've mic'd up the reamer. It is definitely 7.9. So I checked the new valves. I got 3 of them. No, we only need 2, but I thought I'd have one for help, just in case I needed to cut them in. And yeah, put the mic on them, and oh, can we see that in this light? Maybe, maybe not. They're 7.9. They're meant to be 788, and that 7.9 is a good 7.9. Yeah, this micrometer only goes down to hundredths of a millimetre, not thousandths of a millimetre, but it is, yeah, it is just a gnats over 7.9. Like I said, they're meant to be 788, and I've measured all 3 of them, and that is about the thinnest one. Yeah. So I shall be getting hold of the suppliers. What a pain in the arse that is. Like I said, bought them a 788s, hence getting a 7.9mm ream. Yeah, and it's gone tea time. So I'm going to have to wait till tomorrow now. No one's going to answer the phone to me at this time of night. So yeah. Well, I think we'll call that quits for now. Yeah, I've rattled on for long enough. Bugger. Oh well. I was hoping to get further, but you know, evidently we're not going to. So yeah. Yeah. Right. Well done for sticking it out, and we'll catch you in the next one. Hopefully we'll have a little bit more luck. Ta-da.